Okay. So this is called implicit differentiation. And let's take a look at this. Suppose you were asked to find the slope of the tangent line to this curve, x squared plus y squared equals 25, at the point 4, 3. What is this equation if we graph it?
Circle.
Circle. Centered. Origin. Radius. 5. Okay, so let's just get a little mental image here of what's going on. Radius is 5, so here's 5, negative 5, negative 5, 5. I have the ordered pair of 4, 3. We'll just say it's somewhere like that. And we want to find the slope of that tangent line. Slope equals what?
Who thinks of this?
Well, I should expect what kind of number here? A negative slope. Okay. So let's take this equation and solve it for y. Because we haven't done a derivative like that yet, right? Okay, so everything we've had so far has been an explicit equation of y, meaning y equals something. This is not explicit. Okay, but I'm going to turn it into an explicit equation by isolating y. Okay, so I would have to subtract the x squared from 25. What's wrong? Okay. And then I would square root both sides.
What if you did an I?
Not if this quantity was smaller than 25, right? So, and I'm going to use a plus or a minus. Okay, so I'm going to get y equals plus or minus square root 25 minus x squared. Okay, do we need the plus or minus?
Yes.
Okay, if I'm just straight up solving it, yes. But think about where the point is that we're interested in. It's on the top half. So really I'm just dealing with the positive portion. So just straight up solving the equation, you take the square root, always do the plus or minus. But in this situation, I'm really just dealing with the top semicircle. So I'm going to drop the negative and just use the positive. So I'll just kind of put a line through it right there. Okay, so now we're going to take this equation, y equals square root 25 minus x squared, and we're going to take the derivative of it. Because remember, we want the slope of the tangent. Okay, how would you rewrite this first? Raise it to the 1/2, right? Okay, so you take the derivative, I'll take it, and let's make sure we're getting the same thing. Okay, so check up here. Oh, my bad. Thank you. Jeez, I'm on a roll today. Plugged in 4 back here. All right, well, let's...
Oh, that's how you found the y.
Yes, so plugging 4 in here, if I was not given the entire ordered pair, that's how I would find the y coordinate. Okay, but remember we want the slope, which means find the derivative, then plug in our 4. Okay, now let's say that I don't have a calculator, and I want to sub in 4. That's an easy number to sub in. This is a situation where I would want to write it like this. That's much easier to sub in that 4, right? So everybody see how I got to that? All right, so now let's find y prime of 4. Negative 4 over, y'all can do this part in your head.
I can.
Yes, you can.
Don't believe.
Then don't take the exam, because half of it's without a calculator.
Sorry, I'll have these to the
All right, what's 25 minus 16? And what is the square root of 9?
Wait, I got the right answer.
Whew.
Remember, I did it first.
Okay, good. You scared me.
Well,
with
the
the
answer
negative
4/3? Negative 4/3?
Negative 4/3.
Oh, never mind.
False alarm, false alarm. Okay, so that's our slope. Is everybody okay with that number? So now we write the equation of the tangent, which would be y minus 3 equals negative 4/3 x minus 4. Okay, now I don't think I asked us to write the equation, so here is the slope. Question on that. Okay, so that was a lot of work, really, wasn't it? Like we had to rewrite it, take the derivative, kind of rewrite it again. Okay, so this process we used and have been using to find derivatives is called explicit differentiation. This process is accomplished by solving the equation for y, or up until just now, we've had our equation provided to us in that form, y equals. Then we took the derivative. But suppose we were asked to find the derivative of this equation. Okay, just take a look at that. What if I said solve for y there? Could we do it? Yeah, we can't really isolate y because it's involved in two different terms. One of them is cubed, like that. Sometimes it's difficult, even impossible to solve for y. Another technique is needed. Alas, here comes our technique called implicit differentiation. The phrase derives from the fact that there are multiple functions given implicitly or hidden inside the equation without giving us explicit formulas to work with. Often these equations will not represent functions if graphed, like the circle. That's not a function. When we use implicit differentiation, we take the derivative without solving for y. Okay, so here's our process. I'm going to read this to you, and it won't make any sense to you yet. We'll do some examples, then I'll come back and we'll look at this step again. All right, differentiate both sides of the equation with respect to x. Collect the terms with dy dx on one side. Factor out dy dx. Solve for dy dx. Now, this implicit differentiation is a situation where I always use dy dx and not y prime. It just gets it's easy to lose the y prime in these problems. So I always, 100% of the time, use dy dx on these. All right. So we're going to do the same exact problem that we just did. We're going to find the slope of this circle, radius 5, at the point 4,3, but using this new implicit differentiation, and then we'll see which one seems a little bit shorter. Okay, so if I were to give you an equation, y equals 3x plus 2, and I said, what is the derivative with respect to x? What would you tell me? 3. Okay. If I have something like x squared, what's the derivative with respect to x? Okay. So that's easy enough. 2x is the derivative. All right, but what if I just have this little y sitting here and you don't know what y equals? It's not solved like that. It's just some mystery y. This is how I'm going to take the derivative. I'm going to say plus 2y, and then chain rule, take the derivative of y. I don't know what y represents, so I'm going to say dy dx is the derivative of y. Equals, what's the derivative of 25? 0. Okay, so let me go through that one more time. If I am looking for the derivative with respect to x, then if there's an x there, I know what the derivative is, I can find it. X squared, derivative's 2x. But y squared, I don't know what y equals with respect to x. So all I can say is it's going to be 2 times y, and then times whatever y prime is, or dy dx is. Okay? Now, remember dy dx is what I'm solving for. That's the slope, same as y prime. So my next step is going to be isolate this. Get that by itself. I'm going to subtract 2x, divide by 2y. Okay, so I subtracted 2x. I'm going to divide by 2y. Okay, so those will cancel. And I get dy dx equals, the 2's will cancel, and I have negative x over y. Now, evaluate this slope at the ordered pair 4, 3. What are we going to get?
-4.
The same thing. Oh, is it even maybe shorter? Well, maybe a little bit. Okay, so same slope that we found earlier. Yes. So this is what implicit differentiation is. Now, in this problem, could I just solve it for y? Of course, that's how we started out. But there are some problems that you don't have that option of solving for y. And so in that situation, no, like maybe something like that. Well, actually, that one I could too. Oh, there we go. That's a good one. That's a good one that we'll get to, where you just don't really have the option of isolating y. Okay, so in that case, we have to use implicit. Okay, so here we go. We're going to do this next one. Could I solve that for y? Yes. Okay, so that would be an option here, but we're going to do it this newfound way. What is the derivative of y squared? Well, 2y, and then I don't know what the derivative of y is, so I'm going to say dy dx. That's really just the chain rule being used there. Equals 1. I know what the derivative with respect to x is there is 1. I'm going to isolate dy dx. It's being multiplied by 2y, so I'm going to divide by 2y. And dy dx equals 1 over 2y. Okay, go back and see what we're looking for. At x equals 4. Well, that's great. I don't have an x here, so I've got to find y that goes with the x. Okay, so when x is 4, how would I find y? Plug it back into the original. Okay, so I would have y squared equals 4. What is y? Plus or minus 2. So y equals 2 or negative 2. Because I can square both of those and get 4. Okay, so here are my ordered pairs. 4, 2 and 4, negative 2. So we'll evaluate both of those using this formula for our slope. So this is our slope formula. And only y goes into the formula. So I'm going to plug in, let's say, at 4, 2. dy dx.
Wait, don't we just write this down on the bottom?
Yeah, I'm just actually plugging them in. I know you can do that in your head. 2 times 2 is 1/4. And then at 4, negative 2, dy dx, showing you where we're getting this number, 1 over 2 times negative 2 is negative 1/4. Okay, so the slope at 4, 2 is 1/4, and the slope at 4, negative 2 is negative 1/4. What would this graph be if I graphed it?
Square root functions.
Square root function. Okay, so I could solve it for y and get plus or minus square root of x. What does that look like?
Like this.
Mm-mm. Most of y'all are doing this.
Oh, like this. Yes.
Most of you are doing that, but with the plus and minus, it would be both parts.
I thought it would be like.
Here's the positive square root of x. Here's the negative square root of x. That explains why there are 2 points, 4, 2, and 4, negative 2. And why one slope is positive and one is negative. So you've got 4, 2. I'm just going to say it's right there. But then I also have this one that has that tangent. So it makes sense that I'm getting 2 points and then one positive, one negative slope. Because I gave you one specific point that we wanted to find the slope at, and it was on the top half of the semicircle, so we just stuck with the top half. Any other questions so far? All right, y'all don't seem to be freaking out too bad. All right, we're going to use implicit differentiation, and we're going to throw it in with the product rule. Billy, don't scowl at me. All right, so this is a product of 2 functions, right? Okay, so we're going to use product rule. And let's get... Okay, so do you want to start with u or u prime?
You.
Okay, that was unanimous. All right, it wasn't even intentional. U, v prime, what's the derivative of y? 1 dy dx. Now, next step I'll probably take away the 1, but just to show that I took the derivative of that. All right, so that's uv prime plus u prime, what's the derivative of x? 1 times y. Plus, move on to the next term. What's the derivative of y? 1 dy dx, whatever y equals, we're not sure, equals derivative of 8, 0. Okay, so I want to get dy dx by itself. Okay, so what I'm going to do next, let's go back and look at our list of steps. Differentiate both sides. We did that. Collect the terms with dy dx on one side, and then factor out dy dx. Okay, so anything that has a dy dx, I want to keep, I'm just going to say on the left. Anything that doesn't is going to move to the right. What's moving to the right? These are multiplied, so really just the y. Okay, and I'm going to take out my 1s. Let me do that first. That might make it a little more simplified looking. Okay, so all I did in that step is I just didn't write in my 1s. Okay, so these 2 terms are going to stay on the left, and this one is going to move to the right. I'm running out of room. Okay, so once I collect all the dy dx's, now I'm going to factor that out because that kind of makes it look like there's just one of them. I guess I'll just keep going down this way. Okay, so I'm going to factor out dy dx times x plus 1 equals negative y. And then dy dx is being multiplied by x plus 1. To get rid of it, we divide. And dy dx is negative y over x plus 1. So that's our slope formula that can be used in any ordered pair. We're interested in the ordered pair 2, 3. So we're just going to plug 2 in for x, 3 in for y. Negative 3 over 2 plus 1. Negative 3 over 3, negative 1. Not Too bad. Okay. All right. Example 3. Show that the slope dy dx is defined at every point on the graph of this. I have no idea what that looks like, and I'm not even real sure right now how to graph it on my calculator. Okay? And then I want to show that the slope is defined everywhere. Well, let's find the slope first, and then see what it looks like. Okay, so we're going to find the derivative. What is the derivative of 2y? 2 dy dx. Have you figured out that anytime you take the derivative of anything with y, you're going to tack on dy dx? Equals, what's the derivative with respect to x? 2x. What about sine y? Ooh, good job, y'all. Tack on that dy dx because we did take the derivative of something with y. So we get cosine y, chain rule, then dy dx, whatever that is. Okay, so I'm going to isolate these two terms that have the dy dx.
Could you solve this using the chain rule?
We did use the... Oh,
Crazy, Daniel.
lucky! Okay, so say that again. Couldn't we do what?
Like solve it how we learned on Friday.
Meaning what?
I mean, do we use the chain rule when we do this?
We did use, that's why this is here, because of the chain rule. Why did I not use it here? Well, what's the derivative of x? 1. So yes, this is in fact the chain rule right here. Okay, so anything that has dy dx, I'm going to move over to the left. Keep that 2x on the right. What next? Factor it out. 2 minus cozy. Okay, dy dx is being multiplied by that, so we're going to divide. So I have dy dx equals 2x over 2 minus cosine y.
Does it get harder than this?
Not really.
Like this is just the rule
Anytime we have an equation that isn't or can't be written in y equals, then this is the method we use. Okay, so here's our derivative. Let's go back and see what the question was. Show that this slope is defined at every point. How would this not be defined? If what happened? If what was 0? The denominator was 0. Okay, so let's see. Can this denominator be 0? If so, what would make it be 0? Okay, if I had cosine y over... Where is cosine equal to 2? Think of your cosine graph. Where does it reach up to 2? Never. Right? It maxes out at 1, unless I put a 2 in front of it and alter it. But just plain old cosine, it only goes up to 1 and down to -1. So it's never reaching 2. So this is never going to happen. Cosine y is never equal to 2. So the denominator will never equal 0. So therefore, anything will work in this function or formula for the slope.
So why don't we just set the bottom equal? Was that just showing?
Because it said show that it's defined. The only thing that would make a fraction undefined here in this case is if the bottom was 0. Question?
If this 1 instead of a 2
Yes, then there would be at least one value where it would be undefined. Okay, so this slope would be defined as long as the fraction is defined. Are there any values that would make this fraction undefined? No, we already did that above. Okay, next one. Find the tangent and normal, aka perpendicular, to this ellipse. Who knew that that was an ellipse? At the point -1, 2. Okay, we're going to use implicit differentiation. You want to try it on your own? Okay, I'm going to write it out too, so if you need to peek, peek. Okay, I got to interrupt one thing. This second term, we're going to have to use product rule. What's negative and what's positive? Yeah, think of it as plus -x times y.
Plus -x plus 1.
Just one of them is negative, so plus -xy. Maybe after your first step, check up here before you go any further.
So it's not X.
Oops, you know what? Let's see. Did I mess up?
Yeah, why is there a negative?
No, this one or this one?
That or that.
Either. Let's just talk about either. Okay, so I'm going to say u is -x and y is my v. Okay, so this is u v prime plus u prime v.
Oh, so it's not X, Y, dy, dx for the second term.
Correct. You've got to use your product rule with u and v. Okay, any other questions on that step? That was a lot in that one. The u and the v? Okay, so if I think of u as being -x and v as being y, then this is u v prime plus u prime v. Okay, any other questions? Okay, so our next step is to get all dy dx's on one side, everything else on the other. Which side are y'all collecting on?
The right.
The right, I think I will too. No, it's not my favorite, but that's okay. Okay, once you get your dy dx, I'll regroup and make sure we're on the same page. Sean, you're still working? Okay. Anybody have a question so far? All good? Okay, cool. All right, so now let's evaluate this at our ordered pair, -1, 2. So just sub all those in. Let's see, 2 times -1 minus 2 plus -1 minus 2 times 2. All right, -2 minus 2 over -4. That's -4 over -4 is just 1. Did I make a mistake? Okay, so the tangent slope is 1. What is the normal slope? -1. So the tangent line is y minus 2. Oops, that should be an equals. One times x plus 1, and then y minus 2, -1, x plus 1.
We only use this way whenever there's a y that we can find.
Can't isolate y. Or sometimes, like with the circle, we could isolate y, but I think that this is easier. Anything else? Let's leave this one for tomorrow. And let's, because we're still going to work on this more tomorrow, so let's wait for this one tomorrow. I want you to work on these 6 problems today.
You think this is some building? You think this is some building?
What's that mean?
This isn't